everyone. Thank you for the introduction. As it was mentioned, I'm going to talk about alternative ways to detect mimikatz today. My name is quite tricky. It's Hungarian. Actually, it's Balazs Bucsay. Nobody can pronounce it properly except Hungarian, so don't worry about that. So a little bit, even after the introduction, I would like to say a few words about me. I work for NCC Group for 6 years now as a principal security consultant. I'm based in London, UK, and I'm mainly interested in offensive security research, although this talk is about defensive security research, so it's a little bit different than the usual track that I do. I started hacking in 2000 when I was 13 years old. Since then, I'm doing lots of different stuff, but the main thing is offensive security for me. Before COVID, I was a frequent speaker on different conferences. I went to basically 4 different continents, to many different countries. Around here, I've been to Singapore and Melbourne a few years ago before COVID. So if you like my talk and the topic, please follow me on Twitter. You can find me there under X or EIP. Also on LinkedIn, if you want to connect, please send me a request. So let's talk about detection techniques. There are 2 detection techniques that are widely used. There is, the first one is the signature-based, mostly used in AVs, when the AV detection database has strings, and if those strings, binary strings, are matching to a binary or any kind of file, then the AV is going to block, quarantine, or delete that file because that must be malicious for different ways. That's obviously easy to bypass if you know what that binary string is. You can find it in your binary and you can patch it out in different ways. Sometimes it's a string, sometimes it's a set of instructions, but it's quite easy to defeat this detection. There is the other one, which is slightly better, although it might come with false positives sometimes, is the behavior-based. In AVs and EDRs, you find this. Basically what they do, they patch Win APIs, and if you call those APIs in a certain order or from an untrusted process, your process probably will be blocked, might be deleted after a while. This technique is again, not that trivial to bypass, but there are techniques to do that. So this is used in AVs and EDRs. So this topic is basically about finding alternative ways to detect mimikatz in this case. But you will see that the second method can be used for other things as well. We looked into these techniques because we had a few ideas internally in NCC that we might be able to do a non-standard way to detect malicious things. So the first thing that I'm going to talk about is the busy light method, which was basically partly public knowledge already. If you go on that website, which is linked on this side, there is the URL, then you will find a video where the guy explains that if you have a busy light just like this or similar, then you can detect mimikatz with that. I'm going to show you how. So let's cover that first. So what's busy light? Busy light is a USB device, an HID device that you can connect to your computer over USB, and you can flash it in different colors, or you can show different solid lights with this. This kit could be used for, let's say, coders in an open office where you want to signal your state of mind, let's say. You want to let others know whether you can be approached with a problem, people can talk to you, or probably many other reasons as well where you can use that. So if you start browsing the source code of mimikatz, which is open source and it's on GitHub, you will find a module which is called Busy Light module that was introduced in 2015 in October. So it's quite a long time ago, almost 7 years. If you browse the code, and on the screen you can see there are 6 different Busy Light devices that are supported by this code. and was supported by this code by back then. One of the devices is this one. So as I mentioned, this was public knowledge back then and since then. So if you connect a device just like this and you run mimikatz on your computer, it's going to flash in different colors. So probably most of you use mimikatz, but there is this busy light module. I'm not sure if any one of you noticed that previously. It has a few different ways to use it. You can list the devices from mimikatz that are connected to your computer and supported by mimikatz. You can test the light itself, and you can turn it off. But it's really good to know, and if you read the code, you are going to realize that when you run mimikatz, it starts a new thread which is dedicated to talk to this device or any supported device, and it starts to flash that device in the background, and it sends keep alive packets to it in every 5 seconds, and when you kill or exit mimikatz, it's going to kill the light as well. So up until this was public knowledge, but we came up with the idea, what if we can create something new? So instead of deploying this device, mass deploying in DCs where you have hundreds or maybe thousands of servers, virtual servers and such, that might be not a good idea, because who is going to check the lights, right? And how do you connect that to multiple virtual machines on a computer? So it doesn't really make sense. So the idea was, maybe we can create a virtual hardware, which is not going to be a real hardware, obviously, but it can do detection in the background without noticing from the attacker's perspective. So what I did, I looked into this, and turns out Windows is great for many reasons, but one of the reasons is that you can create hundreds of different devices and driver types, and even with those you can create virtual or emulation drivers, so you can emulate different devices. And it's the same with HID devices, USB devices. So I could create a driver that you can install in the user space, and with that, basically, it acts like a normal device, nothing special, and mimikatz or any other tool that uses busy light will think that's a genuine device connected to your computer. So what I did, I used UMDF, which is user mode driver framework, version 2, because that was the easiest for me, and it just makes sense, which means that it only works on Windows 8.1 and up. If you want to support older versions of Windows, you can port the code to older version 1.1 or maybe 1. Probably it will take a bit more time, but it's going to work anyways. So the great thing about UMDF, that it's using user space, so your driver is going to be loaded in the user space. It's going to run as a process. And the privilege level, or the user that as it runs, it's anti-authority local service, which is a really, really low privilege user. So even if there is a bug in the driver, you can't really do privilege escalation, because you will end up with a really, really low privilege user. More than that, the code base in the driver that I created is really low. What it does, if there is an event like start, stop, or keep alive that I mentioned that mimikatz does, it will call an external DLL from a safe space from System32, which can do whatever you like. You can replace that DLL with your own code, and if that happens, you can implement your own actions when mimikatz runs, exits, or sends keep alive. So let's see a demo about this. You can't see my second screen. Just give me a minute, please. The resolution is not the best, is it? bit better. Okay, so it's a Windows 10 machine, nothing special about this. Uh, and everything is going wrong right now, as usual. Sorry, I need to restore this because that's just gone. It takes a little while. It's an old MacBook, so sorry about that. Um, so yeah, so in the external DLL, you can create yours. You can swap the one that I'm going to put on GitHub. Actually, it's already there. Right now, what it does, if mimikatz starts, it calls the start exported function from the DLL, which sends an event to the event log. So what you will see that in the event log, there is this line that mimikatz was started with this PID, which is the process ID. And you will see the same for keep alive, so every 5 seconds there will be a log, and also for exiting. A little bit more waiting, obviously. So when you connect the Bucsay, it's going to flash by default. And again, it's a slow machine, so it takes a little bit of time. Probably it's working already. So when you run mimikatz, it starts flashing, right? Can you see the colors? Can you guess what colors these are and why? It's a flag. So which flag is blue, white, and red? That's right, it's French. And the reason why, well done. Thank you for that. So Benjamin, the author of mimikatz, is French. There is this Bucsay module. Again, I'm not sure if you ever noticed. I didn't before I did the research. You can list the devices, as you can see. This model is connected right now, and you can turn it off, for example, but that's not the most important thing about it. So I'm going to remove it, put it on the ground. We don't need it anymore. And I'm going to install my UMDF driver. It's one batch script. It does the installation in a second. It's a signed driver. It's user space. It's safe to use. And it can be must deployed because it didn't ask for anything. No user interaction needed, right? So I'm going to run mimikatz again. As you can see, no error or nothing. If I use Bucsay and list it, there is another Bucsay module is showing up. So it thinks the Bucsay is connected. So I could do my usual stuff whenever I use mimikatz, but we don't do that right now, so I'm just exiting. And in the device manager, which is the other window, here you see one new device, well actually two, but this is the more important one. This is signed and manufactured by NCC Group PLC. This is my company where I did the research. Well, not my company, but I work for them. And that's the only thing that gives it away, let's say. And in the application log, there are different warnings. Sorry about the resolution, but this is the first one. And again, okay, anyways, that line in the middle, that says tool started, so that when the tool was started at 6:52, and there is the PID, which is the process number. So if you want to integrate it with your SIEM solution, for example, you can get other information about the process as well. And there are several keep alives 5 seconds apart because it's sending these keep alive pockets every 5 seconds. And at the end, the last warning that you get is tool stopped, and that's when it was stopped. So basically you can track the whole life of the process by this way. Cool. So that was the first demo. Obviously it didn't go that well that I expected. And the test results. So partly the reason why we are releasing this technique because we were not that fascinated about the results. So as I mentioned, the The module was introduced on 8th of October 2015. We are just by a few days off from 7 years at the moment. And every version that is compiled from GitHub, either into a binary like an exe or DLL or PowerShell, or the mimikatz that you can download from the release section can be detected by this technique. Same goes for PowerSploit and CrackMapExec. So if you use that as an attacker, you can be detected by this module, this driver that I created. The issue is, for us, that it's not detected by Metasploit, Cobalt-Strike. So Metasploit, Cobalt-Strike, and mimikatz cannot be detected by this technique. We are not surprised at all about mimikatz, which is the Python version of the mimikatz, rewritten by the same toads. But for Metasploit and Cobalt-Strike, it's the same stuff. It's compiled from GitHub. The only thing is that they removed the BusyLight module. I'm not sure why. My guess is not because of this detection technique. The reason is, I think, because they just wanted to get a lighter, a smaller version of the payload, which is easier to distribute. Obviously, if you have a smaller payload, it's just easier and faster, and it's less detectable. So you can't really detect that too with this technique, unfortunately. So the second detection method that we were playing around with is the console driver method. We had the other idea that maybe we can interact with the console itself and get some information about the process that is running and using console through that, and it worked. So basically, in Windows, if you execute a command console application, you might have seen that there is this conhost.exe process attached to it, right? If you haven't, use a Process Explorer and you will see it. So from Windows 8 and up, what happens, basically you have this helper process, let's say, conhost.exe or openconsole.exe, which connects the console with the command line application. There is this driver device in the kernel space, which is called device.conDriver, and the command line application is sending IOCTLs, that's fast IO, using fast IO to communicate with the device and with the console itself. So we were thinking, what if we can snip that communication between the command line application and the device itself? We just need to create a filter driver as such. So I started to explore the idea, and on the first day I realized that Mandiant already conducted this research and they released 2 articles on this, which are great, and these are on the slide as well if you want to look into that. My only issue with the articles was that they didn't release any code, so I couldn't use their code to evolve on this. But a few hours later I realized that there is this GitHub repository, WinConmon, which was created by Eye of Ra, which was great because he claimed that he recreated the same method that Mandiant used, which was partly true. I mean, it was a really good base. I started to use it, but I had issues with it, and it didn't support everything that I wanted, so I created my own code based on the articles and the code itself that I found. So what I created is a kernel filter driver used by, using KeyMDF, which is kernel mode driver framework, which is a little bit trickier than UMDF because the driver that you are creating will be used in the kernel. So whatever you do wrongly, it will end up with a blue screen of that. So it's a lot more risky to develop in kernel space, obviously. So the idea was that with this filter driver, I might be able to capture the IOCTLs, the data that is sent to the device or from the device, and I could check so basically when you send anything to the console, it will be sent by fast IO, and in that payload that it sends, there is the message type, which describes the message itself. It can be like output or input text that you are showing on the console itself, on the screen. And just like in an AV with signature based detection, I match the content, whatever is shown on the console, and if that matching the signature or the string that I'm looking for, I'm going to generate an event, and that event goes to the event log. If you are more curious about this, we can talk about this after the talk, but I don't think we have more time on that exactly. So, sorry, back to the demo first. So that's going to be the second part if everything goes well. And of course, it's gone again. So I'm not sure why that's happening, but I'm going to restore that. I had the same presentation 2 weeks ago in the US, and I had no issues. So what I'm going to show you is basically a different concept in the demo that I just explained. I created one application, which is a GUI base, so you have a nice window, and that creates a name pipe in the background. And the kernel driver, when I install it, is going to connect to that name pipe. It's not the best solution, but I had to be quick and dirty, and that was the way to go. So whatever is shown on the console, whatever is sent to the console or received from the console, whatever is shown in the black box is going to be reflected in that GUI application. This is purely for the demo that I'm going to show you, not for anything else. If you want to do the detection that I just explained, that where I generate an event and that goes into the event log, you need to compile the code from GitHub yourself. Okay, so it's restored. So this is the console monitor, the GUI application that I just explained. So it's waiting for input, and on the other console I'm going to install the driver. So when I install the driver, it's a kernel driver, and as you can see, the output is already, some output from the console is already in the window. So if I do ls, list the content of the directory is shown here. If you are using PowerShell, that's interactive. I'm terrible with this trackpad. So as you can see, as I type, it types in the GUI as well. So you can basically sniff on the traffic. It doesn't have to be local, this is just for the demo. So you can do this remotely over the network as well if you like. And if you run mimikatz, so you can see everything is shown in the GUI again. So you can just match basically the text or anything that is shown on the console to a predefined list, and you can generate events based on that. Okay, so that was the second demo. Back to the presentation. Again, we were okay with the results. This is a little bit better, but not perfect either. So it's great because anything written to the console, either it's interactive or non-interactive, you can match, you can save, you can log, whatever you like. So that's great. And it's not just for mimikatz. So don't get me wrong. This is for all console applications that are out there. The issue is that if it's redirected to a file, that it's not written to the console, right? So you won't be able to log that. Obviously, you can create a filter driver for the file system, just like AVs do that, but you are going to recreate the same thing that AVs already did. So we didn't go that way. So what about the feasibility? As I mentioned, these two ideas that we had internally in NCC, these were research topics. So we didn't expect anything from them. We just wanted to see how it goes. We gained a lot of knowledge from this, mostly me, because I did the research and the coding. So it was really great. For the con driver for the second method that I just explained, I think it's already in AVs and EDRs, XDRs. Since Mandian did the research, I assume it's already internal knowledge for them, and they use it in EDRs just to make that detection a little bit better. So the busy light is really good fun. I think it's fascinating how you can detect things on your computer without the device, but just by virtualization. But obviously that's not bulletproof either. So none of these are perfect techniques, not like previous detection methods, but you can keep them in mind if you might be able to use for something later. I'm not sure if you have any time left. Okay, some. So if you have questions, you can ask them either now or later. There is my email address as well, so feel free to connect with me or send me an email and with a question anytime. I'm happy to answer. Although in the next 2 weeks, I might not be available because I'm traveling around the Philippines. Please follow me on Twitter. And if you are interested in the code, if you want to use the code itself, it's on GitHub. Both of them are released now. It was published, the second one published a few hours ago. The first one in 2 weeks was released in 2 weeks. So yeah, it's available. Any questions for now? I can't see any hands. Okay. If no questions, or if you are just shy to ask, maybe after the talk, in a few minutes, you can catch me, or in the evening, if you get me a beer, I'm really happy to answer any questions that you like. So, okay, cool. Thanks. Thanks for having me.
All right, thank you so much. Now, so why wait for later for a beer when we could have some whiskey now, right? So, cheers, mate. Good talk. All the way down. Good job. Thank you so much for that wonderful talk. So that was very interesting. Now, we've always loved mimikatz. I've been using it for a very long time, but it's really good to see that there's a way to catch that as well. So, so again, if you do have questions for Balazs, I hope I said that right. Feel free to reach out. He's just around the place. If he's not here, he's probably backpacking somewhere. Okay, so yeah, while we wait for our next speaker, I'm just gonna be stalling for some time. That's what they told me. So it's really it's really good to see everyone again after 2-3 years of the pandemic. We had to make do with doing a remote conference, and it's good to see people here. Although I'm seeing a lot of people grow a bit to the side, which is all right. It means we are all healthy and doing good. By the way, I'm just curious. Is there anyone here who were able to join us since ROOTCON maybe 1? Probably just the Goons on 1. How about 2? Beer Talk 2. It was, we used to call the conference, before we were ROOTCON, our first was, we had started with DEFCON PH. We started as Beer Talk because we just wanted to have beers while giving talks. So, started Beer Talk 1 and Beer Talk 2. Anyone who was here from Beer Talk 2? Don't worry, we won't be counting age here. Maybe you just started young. Anyone from Beer Talk 3? Goons not counted, of course. What? I do know that a lot of the land back guys here. They usually are our most avid attendees.